Okay, welcome back. Our topic for today is on probability in measurements. The first type of probability that I'm going to discuss with you is the probability of independent events. It is given by the rule probability of event A and event B happening is equal to probability of event A times the probability of event B. Before we go on any further, let us define independent events first. Two events are independent if the fact that A occurs does not affect the probability of event B occurring. An example. What is the probability of getting an even number when a die is rolled and a head when you flip a coin? These two events are called independent because the event A occurring, which is you getting an even number when you roll a die, does not affect you getting a head when you flip a coin. Let us now look at the multiplication rule and apply it on our problem situation. So the probability of getting an even number when you roll a die is 3 out of 6. Why so? Because in a die, there are 3 even numbers and there are 6 faces. That is the probability of getting an even number when you roll a die. Let us now go to the probability of getting the head when you flip a coin. Coins or a coin has two sides, and the probability of getting the head is 1 out of its two sides. Therefore, the probability of getting an even number when you roll a die and a head when you flip a coin is 1 out of 4, 25%, or 0.25. Let us now go to example number 2. A card is chosen at random from a deck of 52 cards. It is then replaced and a second card is chosen. What is the probability of choosing a king and a 2? Let us clarify one thing here. When you pick a card from the deck of 52 cards the first time, you have replaced that card that you have taken and put it back on the deck again for you to choose the second card. When this happens and there is a replacement, the probability of the two events become independent because you have replaced the card or you have returned the card that you have taken. When a card is not replaced or when a first card is not returned to the deck and you choose a second card without the first card that you have chosen or that you have picked, that becomes a dependent event. So again, with replacement, it is independent. Without replacement, it becomes dependent. Let us now apply the rules. Probability of getting a king the first time is 4 out of 52 in a deck of 52 cards. The probability of getting a 2 when the first card was replaced or was returned in the deck of 52 cards is 4 over 52. Therefore, the probability of getting a king first and a 2 on the second with card replacement is 4 over 52 times 4 over 52, which will become 16 over 2,704, or 1 over 169. The second type of probability is the probability of dependent events. Definition. Two events are dependent if the outcome or occurrence of the first affects the outcome or occurrence of the second. An example. From a deck of 52 cards, a card is chosen at random without a replacement. What is the probability that the first card is a jack and the second is a queen? Let's analyze. So the first time, you want your card to be a jack. The second time, without a replacement, meaning to say you did not return the card that you took the first time, you wanted to be able to draw a queen. Now let's start the solving. Solution. The probability that you get a jack on the first pick is 4 out of 52, meaning to say there will be 4 jacks in the deck of 52 cards. I hope that makes sense. the next time. You would want to calculate the probability that you will have a queen on the second pick, given that the jack was already chosen on the first one. So I want you to look at what changed. So here you had 4 over 52, and here you still have 4 over 51. Why 4? Because you are still anticipating that there are 4 queens in the deck of 52 cards. However, because the other card was not replaced, the 52 now turns to a 51. By the probability multiplication rule, we are now going to calculate the probability of picking jack and then a queen in the deck of 52 cards to be 4 over 52 times 4 over 51, which is 16 over 2,652, or 4 over 663. Moving on further, some other definitions. Conditional probability. The probability that event B occurs given that event A has already occurred. Okay, so some notations. This notation right here is read as the probability of event B given A. In other words, the probability of event B happening when A has already occurred. The way to calculate this type of probability, which is conditional probability, is get the probability of event A happening, multiply it to the probability of B happening when A has already occurred. An example. Anne is given a bag of 12 mints and 8 kisses. Randomly, she chooses a candy to eat. Now, what is the probability that her first candy is a mint and her second was again a mint? So, let's calculate. The probability of getting a mint the first time is 12 over 20. The probability of getting a mint on the second time, given that you got a mint on the first time, is 11 out of 19. So the probability of getting mint 1 and mint 2 is 12 out of 20 times 11 out of 19, which is 132 over 380, or 33 over 95.